Hi guys, so today I'm going to show you how to do the data analysis for the kinetics lab that we just did. So the first thing you need to do is go into your Google Drive and get yourself a shiny new spreadsheet. So from here, once this does its thing, we need to import your CSV file. So import that data file that you saved from the laptops in the lab. So you'll click on File and then Import. And ideally you'll have it saved on your computer somewhere, so you'll need to upload it from wherever you have it saved, whether that's on your desktop or a flash drive. It'll appear over here. Navigate to it like you normally would. I've got mine on the desktop right here. So that will take just a second to upload, and then you'll be given this little screen of options. It doesn't really matter which one you choose for the import action. I'm going to replace my spreadsheet since it's empty anyways. Doesn't really matter. For the separator character, you do want to click comma because we used a CSV, which is a comma separated values file type. And then click import and wait for that to do its thing. So ideally you will have two different columns of data. You should have one that's titled time and one titled absorbance at some wavelength. This wavelength should be whatever lambda max you were recording at. If you have any additional columns of data, you probably saved the first run that found the absorbance at every wavelength to determine lambda max. If you have any extra columns of data, you can delete those. You can just click on, right-click rather, on the column header and click on Delete Column for any additional columns. So these are the only two you need to save. I'm going to put in a few extra columns now since we're going to need them shortly. So what we have to do from here is use this data to plot concentration versus time, natural log of concentration versus time, and 1 over concentration versus time to figure out which one is linear, to figure out the order of this reaction with respect to potassium permanganate. So we need to convert absorbance to concentration. And to do that, we need to use Beer's law. So Beer's law tells us that the absorbance is equal to the molar absorptivity times the path length times the concentration. So before you can do anything in the spreadsheet, you need to calculate the molar absorptivity based on your data. The path length is 1, you were using 1 centimeter cuvettes, and the concentration you can calculate based on the information you have about the solutions that you used. So the concentration is referring to the concentration of permanganate in the solution you prepared in part 1 of the experiment, where you took 1 milliliter of the potassium permanganate, which was 0.002 molar, and you added 4 milliliters of sulfuric acid to that. So you diluted that 1 milliliter up to a total volume of 5 milliliters. So finding this concentration is just a dilution problem. And then you have the path length and you have the absorbance at lambda max that you recorded in your lab notebook. So the only thing you don't know is the molar absorptivity, and you can solve for that. So you're going to need that number going forward. So if you haven't done that, do that. So from here, we're going to need to use the molar absorptivity to solve for concentration at different absorbances. So we need to solve for concentration. So if we rearrange Beer's law, we see that concentration is equal to absorbance over A times B. B is 1, so mathematically we can kind of ignore that. But the rest of this expression is going to be important. And we're going to use that in our spreadsheet to get concentration data. So we're going to make a new column for the concentration of potassium permanganate. And we're going to get the spreadsheet to calculate all of these for us. So we're going to start in cell C2, the second one in the third column, and type an equal sign first. So starting with an equal sign tells the cell that it is going to do math when you press enter. So what we need to do is convert the absorbance into concentration. We said that the concentration was absorbance over molar absorptivity times path length. Path length is 1. So we need to take our absorbance and divide by the molar absorptivity. So the absorbance is in cell B2. So we have equals whatever number is in B2 divided by whatever number you calculated for molar absorptivity. Based on my data, I got 1465. And I can press enter, and that gives me the concentration at time 0. So if I want the concentration after 1 second, I come up to this cell and copy it and paste into the next line down. And you'll notice that the number has changed, and it's not referencing B2 anymore, it's now referencing B3, so it's using this absorbance to calculate this concentration. So you can copy and paste this all the way down. You can click and drag all the way down the column and paste in one fell swoop, and it calculates all of your concentrations for you. The next thing we're going to need is the natural log of the concentration. So we can plot natural log of concentration versus time. So now we're going to start with equals. Natural log is the function we're going to apply. Open parentheses, and then the value we want to take the natural log of is this concentration right here, which is in cell C2. Close parentheses, press enter, and you've got your natural log. So then again, we can copy that cell and paste it all the way down to apply the same formula. And we've calculated the natural log of the concentration at every second we recorded. And last but not least, 1 over the concentration. So again, we start with the equal sign, and now we want 1 over the concentration, which is in cell C2. Press enter, and we've got that value. So one last time, we copy and paste all the way down the column. So now we've done all of the major data manipulations we need. I'm going to add a few extra columns just so the graphs we're going to make kind of have some place to go. So we need to make 3 graphs, concentration versus time, natural log of concentration versus time, and 1 over concentration versus time. And the one that's linear gives us the reaction order. So to do that, without selecting any data first, is what I found works best in Google Sheets to not confuse it. We're going to click on Insert, and then Chart, and select our data range in here. So you want to click on this little grid that says Select Data Range, and select the time data first. So select column A, click and drag down, and click OK. Nope, sorry. Click Add Another Range. So we've told it our X data, and now we need to tell it our Y data. So in the Y axis, we want the concentration for our first plot. So we'll select everything in column C. And now that we have both the X and Y defined, we can click OK. We want this to be a scatter plot, not a bar graph. So you're going to come over to Charts here to change the type. Select Scatter and this first type, and you get a little preview here. And we can insert that, and it should be up at the top of the sheet. So this was our concentration versus time plot. Give it a little title so we don't forget which one's which. And we can see that this data isn't really terribly linear. It's fairly curved, so probably not a zero order process. So next we want to do natural log versus time. So again, insert chart. We're going to select the data range, the time first. Click and drag to select that. Add another range, and this time we'll select the natural log column, which was column D. There we go, and we can click OK. Change the type to scatter again, and insert. So give it a title, natural log of potassium permanganate versus time. And so this one's looking nice and linear, so this is probably a first order in permanganate process, at least according to my data. But we've got one more chart to make to check the second order version. So once again, insert chart, Select our data ranges, time first, add another range, and select the 1 over concentration column. OK, change the chart to scatter, and insert. So this one we can also see has a fairly significant curve to it. So title, 1 over concentration versus time. So we have our 3 plots, and the one that is pretty clearly the most linear is the natural log of concentration versus time for the data that I collected. So whichever one is linear is the one that you're going to want to use going forward. So the concentration versus time means that the process is 0 order in permanganate. Natural log versus time is 1st order in permanganate, and 1 over would be 2nd order in permanganate. So for whichever one you used, you need to find the slope of the linear regression in order to get k. So remember that k is related to the slope of the linear plot for whichever one of these comes out linear. So to calculate k, one of the shortcomings of Google Sheets is that, as far as I can tell, there's no way to get it to show you the equation of the linear regression line. But what you can do is get it to calculate the slope directly. So instead of just writing the equation on the graph like you might do in Excel, you have to calculate it a little bit separately, but that's not too hard. So if we want to find the slope of our linear regression, you will type in, pick a cell anywhere that will say that's going to be our slope of our line here. We'll type in equals slope. So calculating the slope of the line from linear regression of data is what we're going to do. So slope is our function. We're then going to open parentheses, and this little pop-up tells us that it wants to know our y data first, then a comma, and then our x data. So our y data, we're going with the one that was most linear, was the natural log. So we have natural log of concentration as our y data. So we're going to select that range. So it tells it which cells that is. Note that I did not select the column header on this one. So I didn't select the one that's text. You want to only select boxes that have numbers in this case. So it knows our y data. Then to tell it we're moving on to x, we want to put a comma in. And then our x data was time. Again, we're not selecting the column header, so we're starting in cell 2 in this column and going down to cell 302. So then when we close the parentheses and hit enter, this is going to calculate the slope of the linear regression of that data. So this tells us that our slope is negative 0.00335, and then k is equal to the negative slope. So this would be equal to the opposite of cell G62. So we now have our value of k. And that is all you need to do in terms of analysis in the spreadsheet. Beyond that, it's just writing up your results in your lab report.